So this is an introduction to probability and sample space itself. Now, unfortunately, we were going to do this in class when it came to it, but I'm just going to make up some numbers for you guys when it comes to it. And then you can just write this down in your workbooks. Okay, give you a quick minute just to write that down. And then what I want you guys to do is fill out the rest, right? So, what would these boxes end up being now when it comes to it? So get a quick to pause, 3, 2, 1, pause. All right, so hopefully you fill out the portion, right? So just the sum, so 4, 1, 2 is 7, 5 plus 4 is 9, 7, 8, 9, 11, 4, 5, and 8. So if we go to grand total across, it should be 35. And same thing on the other side. So this one should be totals going across. So this should be 5, 8, 10, and 8. And notice it should give you 38 also going down the list, and hopefully it does if I did my math correctly. Oh, what am I off? Ooh, this one's off. This should be 14. There we go. There's 14. All right, there we go. Now we get 35 each way. Okay, so this is essentially a probability question, right? So here's the information we have. Now, using this information, why don't you guys try the next couple questions here? So I'll give you a quick pause. Well, you can go all the way to G, and I'll put the other one. So 3, 2, 1, pause. You can try all the way down to G as well. And the back has one last one there. Okay, so hopefully you guys try these out. Pretty straightforward questions, right? So question A says, how many students in our class have brown hair and green eyes? So brown hair and green eyes. So there should be 5 people, right? So we have, in this case, virtual students, 5 virtual students. B, how many black hair and brown eyes? So black hair and brown eyes. Should have 2. And we just go down the list, right? So C, how many students in our class have brown hair? So just brown hair. So if you just go how many brown hair total, it should be 14. And how many students in our class have brown eyes? So now we just look at the eye color, and that should be 11. So hopefully this wasn't too bad to deal with when it comes to it, right? Now E says, what do the values at the bottom row represent? So the bottom rows. So these ones here. So hopefully you say, right, it's the number of eye color of our students itself, right? So that's how many total eye color we have individually. F is identically. What are the values on the right column represent? So these numbers here. So these represent the number of hair color we have, right? So how many total blonde hair, red hair, all that portion, right? So this tells us 2 different things. That's the whole thing that they're trying to get to. Going down tells you what's the eye color, total eye color. Going across tells me how many total hair color we actually have itself. So there's 2 different things happening in this table. Okay. All right, in that portion, let's go to H. It says, what fraction of students in our class has brown hair and brown eyes? Okay, so what fraction? Well, let's just first start. How many have brown hair and brown eyes? Okay. So brown and brown, so brown hair and brown eyes. You only have 1. So we want a fraction though. This would be 1 out of what? What do you guys think? Hopefully say 35, right? Because there's 35 students in the class. So there's only 1 person in our virtual class out of 35 that has brown hair and brown eyes. Okay. Now it says the other question is, what fraction of the students in our class has green eyes? So we don't care about the color of the hair, right? Just the number of green eyes. And total green eyes we have 9. So it'll be 9 students out of, again, 35, right? We came to it. So hopefully these weren't too bad when it came to it. So what I want you guys to do now is try this one out. So there's a new one on the bottom here. So, figure out some kids, if they, how popular kids are amongst their portions. And here's a table itself, and you may have to, fill this stuff out when it comes to it. And now go ahead and do A and B respectively. So I'm going to just do a quick little 3, 2, 1 pause, and try it out. Okay. So hopefully you got it out. So now let's do this together and see what we get, right, when it comes to it. So all we have to do is just fill out the columns, right? So we're just going to add down. So 94, 34, 165, 185, and the grand total is 478. And same thing applies here. There we go. And now we answer the questions. So question 1 says, or A says, what proportion or fraction, so same as the one we did above here, of the total number of students considers looks to be the most popular factor? So looks. Among their, so looks. So it's right here, right? So looks. So total of 185 people said, out of how many? 478. Okay, so very similar to what we did. Now, here's the thing when it comes to probability. So this is actually a probability question. That's all it is. In most cases, just going to put it into decimal form. So when you divide this, you get give it to me like that as well. Okay. Now let's look at B. B is a trick question when it came to it. B says, if you were to randomly select a boy, what is the probability or fraction that he would think money is the most important factor among many of their friends? So this one always gets a lot of people. So I'm going to put a couple answers down you guys may have gone. So did you see if you guys got at least one of these answers I'm going to write down? So money is here. So did anybody get 1 out of 34 as one of the answers? What about 1 out of 478 is another question I see. What's another one that could be possibly? 34 out of 478. And another one is 17 over 227. That's another one I see a lot as well. So these are the most common ones I see. Oh, actually, there's one more. That one. So believe it or not, the answer is actually one of these five. The question becomes which one it actually is. And that's what probably comes into play. And the wording of how the question is huge when it comes to it. So first of all, it says, we're not selecting a boy. So a boy is one person, right? One boy in this concept. So that's why, this makes sense, right? One person, and one person, right? We're selecting a boy. But what I see, the argument behind that is, well, I don't have one single boy in my class, right? I have multiple boys in my class. So that can't be right, because if I just say here, 1 out of 34, all I'm picking is the people from the money. Right, well, what about everybody else? This is saying there's only 34 students in the class, but we know there's a total of 478. So this one's right off the picture because of that, right? You're skipping, you're throwing away all those other people when it came to it, which, should be implied in your portion. This one's also a pretty interesting case, right? We want a boy, but the problem is we're not, the question says one single boy, but how many boys do we actually have in the class? 227, right? So I'm picking one person. So again, if I am in a classroom, I'm picking a boy, right? But that doesn't mean there's only one single boy to apply. And the reason why this is actually incorrect is because we're picking one person out of the entire class period, right? That's it. What this is saying, there's only one person in here that picked money. And that's completely wrong, right? Because we know there's 17 girls, 17 boys picked money, and we're saying only one person picked it, which is incorrect, right? We have multiple corresponding torpid tables. And then finally, this one here. Okay, so what this is saying is one boy, only one boy, picked money. Out of all the boys, only one boy picked money, which again is incorrect because we know 17 boys picked money, not one boy, correct? So this one's out of the picture because of that as well. So now we're down to 2. Which one is it going to be? Well, let's look at this one here. This one says 34 boys picked, out of the 478 people, 34 boys picked money. Well, again, that's not completely true because there's only 17 boys that picked it. So this one can't be right as well because that means this is including the boys, the girls as well. So what I'm going to do is I'm going to pick this one as well. I'm going to add that extra one in there. So give you a hint, it's going to be one of these two for sure. The question now is which one is it going to be? So let's look at this one. So this one says exactly what I said earlier, right? 17 boys, which is what I want. So only 17 boys picked money out of a total of 478. This one says 17 boys picked money out of 227 boys. So which one is the right answer? Well, for that we have to go to the actual question again. It says, if you were to random select a boy, meaning we're only looking at the boys themselves. So the question becomes, which one of these two answers only specifies boys? Notice only this one because this is the sum of all the boys and girls. So I'm only looking at the boys, right? So again, in the classroom, I am only going to pick the boys. All the girls can move to the side. I'm going to pick, who has red hair or blonde hair when it comes to it. So the true answer is actually this one here, 17 out of 227. Okay? Because again, 17 boys picked money out of a total of how many boys in the class. Again, because we're only choosing of the boys. So this is why it's a trick question. And why a lot of times probability could be very tricky depending on what the question actually asks. But it's a good little exercise anyways, okay?